we just measured a real object, our two speakers, with music playing. And now we can go to the analyzers, the sound camera module. We start the sound camera module and see what happens. It asks us if we want to use the default USB MPC data. Yes, we want to do that. And there are no results already calculated. What we see here now is the time and the frequency in one diagram. So we can analyze our real object. There are 6 seconds measured as we set it up. And I would like first to put a weighting filter on it, an A weighting. And then see how it looks like. Okay. What we can see now, there are some lines and some hotspots. That means in this time, for example, in this period of time, there is this frequency with a high level. So what I can do now is just figure out, for example, if I want to see this spot where it comes from, I draw a rectangle like this. I see there is a new frame coming up, and for example I draw a second rectangle like that. And now I did one mistake, and that makes me to delete the last frame again, because when the first frame is set up, it is very good to go to region of interest and type in the correct distance for the analyzers. So, and just use this zoom out button to have the whole area of analyzing. So, and then I go back to time frequency graph and draw the second rectangle again. And now this is active, the rectangle number 1. And when I go to region of interest, there is already the correct distance in there. So that could be 2 things that are interesting for me, 2 events in the acoustic data that are of interest. And the region of interest is already set up, and easily I could go to beamforming, use a standard beamforming algorithm, and use this button to calculate both of these frames. When there is a yellow lighting, that means that the settings of the frame are alright, but there is no result available. That means we have to calculate both of them. So, and this button calculates all yellow lighting frames, and this button calculates only the active one, that is this one. I would like to see both of them, so I calculate both, and now you see the first frame is calculated and then the second frame is calculated. And the calculation time is depending on the time and frequency settings. That higher the frequency, that longer is the calculation time, and that longer the time in the frame, that longer is the calculation time. So, and when the calculation is done, we will see the results on this screen, the acoustic picture screen. So now we see the second frame finds a sound source onto the left speaker, and let's see where the first frame is. Oh, it's also the left one. So perhaps we can find a spot in the music playing where the right speaker is more involved in. So we can easily toggle between the results, and we can easily go back to the music and find some other interesting parts in time and frequency, go to beamforming and just calculate them. And then let's see what happens in the picture. It's again, both speakers are active because it's stereo music, but they should not always be the same. So let's see if we can find something else. For example, this tiny spot, or this one, or that one. And go to beamforming, calculate all of these 3 new spots, and see what happens with the results. acoustic picture. That's only the left one, and the left one is stronger again. So let's see if we can find a spot where the right speaker is more active than the left one. Let's see what's about this. Go back to beamforming and calculate again. Go to acoustic picture. So now we found a noise source that is placed on the right speaker. So what can we do else? We have several controls for zooming on both axes and other things we can do. Just try it, play around with it and see what happens. For example, we can drag and drop this tiny cases, make it bigger or smaller, and now we see in this frame there is a red dot, a red light, and that means that you first have to apply the changes, and then of course the result is not longer available. So apply and remove the result. That means we have a yellow light now, and we have to recalculate it again, and we will get a new acoustic picture for this frame. That's different to that we had before. So that is in general the area of this acoustic picture, acoustic camera module.